I would encourage then, if that's going to happen, if you miss an example or if you miss whatever, to watch the recording for what you missed, just that part. And I try to break it up into chunks. I don't know if you've been checking out the recording. You may not have been because everybody's been here, and I really appreciate that. I can't tell you how much I appreciate seeing all of you. This is huge. So I try to break it up into chunks and you can see, so you don't have to watch the whole thing. But yes, I can also, I don't know what is happening with class on Wednesday. I'm not quite that far ahead, but I can look and see. If we want to, we could start early. I can do a survey and we could start early if we wanted to. I don't know if that works for people or not. That would get around it as well. Does anybody want to do that? Do you want to start early on Wednesday instead? No, yes. Does that cause problem?
I have class at 10:30, 11:20, so I can't.
Okay, so no. All right, then we'll just do the same thing. We'll record. I'll see what I can do to keep it short-ish, and if you have to duck out, you have to duck out. I get it. I understand. Okay, other questions? Anything else at this point in time? You should have gotten back your homework and you should have gotten back your tests. Give me a thumbs up. Those came through. Yes, you could read my handwriting. Yes, good. Okay, cool. I was telling, I think either cryptography or foundations, that one of the very few benefits to doing teaching and learning this way is that you don't have to wait till the next class period to get your tests back. So sometimes you get them back faster. Very few benefits. Very few benefits. That's it. Group work is due today at 2, and I did not set up the group work in groups because I didn't want to presume that you were doing it in groups. So I saw a couple people, if you submit it once, as long as everybody's name is on it, that's fine. Not everybody has to individually submit it. I will figure it out. Just make sure that if it's multiple people, just submit it once, but everybody's name is on it, and then I'll figure it out. So questions about the group work? Do it too? Anything there? Stuart, yeah.
I submitted mine, but it was with me and Josh, but I forgot to write his name on. I commented it.
You gave me a comment. Yep. So
okay.
I'm fine there. You can do it in the comments too if you want to say who it applies to. And honestly too, if I know who you're mostly working with, so if I get one without everybody's name on it and I didn't get one that I would have expected from someone else in your group, I'll give them the score. I know, I'll email and ask to see, but yeah. So at 2, please. Other things, other questions? Okay, so 12 more class periods left. I'm not sure if that sounds better or worse than 3 weeks. I don't know, but 12 more class periods left, plus the final exam, and I'm still trying to decide. I will have an answer for you by the end of the week in terms of whether the final is cumulative or just on chapter 5. So I will get you an answer on that by the end of the week. I would say I'm 50-50 right now, trying to decide. Either way, the exam is during our regular normal exam time, which is Wednesday, May 13th at 10:30. So it shouldn't conflict with anything else because it's during our regular exam time, and exams are normally set to not conflict. So we've got that going. I will get you an answer about cumulative or not. Anything else? Other questions before we jump into chapter 5? Going once, going twice. All good? Okay then. All right, so chapter 5, let's get a whiteboard up here. Chapter 5 deals with systems of differential equations. So that's what we're talking about in chapter 5, systems of differential equations. Sorry, just trying to be able to see as many of you as I possibly can, which is not very many of you at this point in time, but we will get a few of you up here. All right, so section 5.1 is first order systems. So previously, here's where we were at. Previously, we had one independent variable at the beginning of this semester. It was X. Further along in this semester, it was T, right? And T makes more sense, especially as we're talking about a differential equation modeling the motion of an object on a spring moving back and forth, or a differential equation. It's been a long time since we did this back in chapter 1, but a differential equation can also model, do you remember when we did mixture problems and put water in tanks and then put concentrate in tanks and a solute and all that fun stuff? So time can represent as stuff is going along with mixing liquid in a tank. And then we also had one dependent variable. For that, we were using y, or sometimes we were using v. Remember when we did volume, we were using v, or we were using capital P for population, capital P, or sometimes we used x for motion. There's other ones, but those are kind of the main ones that we talked about up to this point in time. So dependent variable, right, depends on, cleverly named, depends on the independent variable. The independent variable just keeps going along. The dependent variable changes based on the independent variable. That's what we did up to this point. Now, in chapter 5, we're still going to have one independent variable. And it's still going to be x or t. Usually, I think it'll be t in this case. So let's just say t, knowing that I can come back to x if I want to. But usually, this one's going to be t. And we'll have 2 or more dependent variables. 2 or more dependent variables. And usually these are going to be x, y, z, etc. Or sometimes they are x1, x2, x3, etc. So we'll use both notations. You should get familiar with both. X, Y, Z are usually used when there's 3 or less, 3 or fewer. X1, X2, X3, etc. are used when there are 4 or more. So no right or wrong for either way, just different notation on both of those. And as a FYI, if you wanted to do 2 or more independent variables, because that's the next natural extension of this, right? You can. That would then be a class in partial differential equations because you'd have 2 or more independent variables. So you'd have to take partial derivatives, right? Partial derivatives, this should be bringing back at least some small memory for most of you. This is actually, Dr. Brown in computer science would love to teach a class in partial differential equations if we ever got around to offering it at some point in time. I don't want to say that's his research area because I think that's a little too strong, but he definitely does work in that area. So partial differential equations. Technically, we have a class on the books at WLC. Practically speaking, I have no idea when it's been last taught. So it exists, but not super recent or anything like that. All right, so now what we have is instead of a differential equation, we have a system of differential equations. And therefore, instead of our solution looking like just one function, right? Our solution instead is going to look like 2 or more functions. So our solution would be x of t equals something, y of t equals something, maybe z of t equals something, or you could do x1, x2, x3, etc. All right, so we're going to 2 or more dependent variables and therefore 2 or more solutions. Think about it with algebra and the way we usually do this, right? If we have a system of equations with x equals and y equals, then our solution would be x equals a number and y equals a number. You need both halves of the solution in order to solve the system of equations. Here, you need x equals a function and y equals a function, maybe z, depending on how many you have. And so you also need all of these answers in order to get a solution. Okay? All right. Let me stop sharing my screen so I can see you all for just a minute. Give me a thumbs up that is kind of sort of making sense before we do some examples here. Okay, good. All right, practical applications of this. So we're really good at practical applications of one differential equation, right? Motion of an object in a spring, liquid in tanks, etc. The natural extension of this would be if you have 2 masses and 2 springs and they're somehow connected, moving back and forth, interconnected, or if you have two tanks where liquid is flowing. So maybe liquid is flowing into one tank and then it flows out of that tank and flows into the next one and then flows out or fills up. So if you've got multiple things going on in your physical system, then we would set up a system of differential equations. All right. Do you remember how we solved differential equations in the first place? We took baby steps, we played around with stuff, we said, let's see what methods we can come up with, and then we said, these are not very systematic, and they don't scale well, and they don't generalize well, and we need better methods. Kind of sort of remember that? We played around a little bit, right? We're gonna do the same thing here. Today, we're just gonna play around a little bit. We're gonna play around with some of these systems. They're only gonna be first order from the title of the section. So they're only gonna have first derivatives. We're gonna do some playing. I'm not gonna give you any concrete techniques or anything to do systematically. I just want you to play. And then after that, we're gonna say, we can keep doing this if we need to, but it would be better to have a systematic process. So we're gonna try to get a systematic process after our initial playing with stuff today. That's the plan moving forward. Good? Making sense? Plan moving forward? Okay, all right. So